Welcome back once again. My name is Mr. Charles Wenike. In today's video tutorial, we'll be discussing on what is a power diode. We'll discuss on the application of diodes and working principle of power diodes and other things that are involved. But before we proceed on this video, please, I would like to say, if you like my video, subscribe to my channel, comment, like, and share. Thank you once again for watching. So in that case, let's go straight to the point. I have made some videos in this channel as well. You can also watch um, my videos on Charles Electronics tutorials. That is where you can see my videos on electronics components. So in that case, a power diode is a two-terminals device. A power diode is a two-terminal device where one terminal is an anode. This anode is positive. This anode represents plus, and the second terminal is cathode. Cathode represents negative. So in that case, this anode is telling you that it's a P type, while the cathode is representing N type of material. So in that case, in diode, it has only two terminals, the positive and the negative. So in the position, the current through the power, the current in this position, the current through the power diode increases steady, and the voltage also increases. That is to show you that as the current increases, the voltage increases. Please, if you don't understand the difference between current and voltage, I have already made that video previously on current and voltage. The difference between current and voltage, I have made that video. I also want you to know that current cannot move without voltage. Current cannot move without voltage, while voltage can move without current. That is to tell you that voltage is always waiting for current to enter, then voltage pushes the current, and that is how it works. Just go and watch that video if you enjoyed it. So in that case, in this position, the current through the power diode increases, and the voltage also increases. So that is how it works. So in that case, when the diode is reversed bias, only a small current flow through the diode. This is called linkage current, and this linkage current, it is when the diode is in reverse bias, and a small linkage current and a small current will be flowing through that diode, and it can be only be visible if you can use maybe analog digital multimeter, because for me, and the meter that I use often is digital multimeter, but I have some colleagues, friends that we work together in terms of electronics, and I have also seen it in transistor linkage current in transistor. It happens. Not knowing that that transistor wasn't in a good shape. We were all thinking before the young man tested it, and the transistor was leaking current, and I told him that this is a linkage current. That is to show that that transistor was not able to perform efficiently, and that is exactly what happens here. So in that case, it is called linkage current. Let's go straight to working principle of power diodes, how it works. If the anode voltage is higher than the cathode, that is what I mean by anode is known, just as I explained before. This anode voltage is P type voltage. It represents positive voltage. Is higher than the negative voltage. Then the diode is forward bias. Let's say if the voltage of anode is 10 volts, while the voltage of cathode is 5 volts, that it simply means that power diode is in forward bias. That is, I just want you to understand it in that form. Now, just as I said, this anode represents positive, while the cathode represents negative. So the range of forward voltage drop in this diode is very small. It's approximately to 0.5 volts, from 0.5 volts to 1.2 volts, 0.5 volts to 1.2 volts when in times of voltage drop, when that's when the range of forwarding voltage drop in in that particular power diode, as the process of moving, there is some little voltage drop, and the voltage is not, it won't be as big, it will be very small, approximately from 0.5 volts to 1.2 volts, and it will not affect the working principle of the diode or the circuit. In this mode, this diode work as forward characteristics, just as I said. In this mode, it work as characteristics since 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 the voltage of anode is greater than the voltage of cathode. So inversely or proportionally, it is working as a forward characteristic, that is forward bias. So if the voltage of the cathode is higher, now if the positive voltage, if the negative voltage is higher than the positive voltage, it simply means that the diode perform as blocking mode. The diode perform as a blocking mode, which is too bad. It won't work like that. So that is to tell you that it must, once it happens to be that you have confirmed that the voltage of the anode of the cathode is higher than the voltage of the anode, it simply means that that bios is performing as blocking mode. It blocks voltage that is coming or going. So in that case, in this mode, the diode perform like the reverse characteristics. That is, it's reversing. It means that the voltage is returning back to the source. It means that the voltage is returning back to the source. I repeat, if the voltage of negative is greater than the positive voltage, it means that that performance is called blocking mode. And with that mode, it performs like the reversing characteristic. It's reversing the the voltage back to the source. Power diode voltage rating. Power diode voltage rating. Voltage rating, it has two types. One One is repetitive peak inverse voltage. Repetitive peak inverse voltage. The other one, and it has VRRN. The other one, the second one is non-repetitive inverse voltage. It has VRN, not VRRN. Now, how do they work? I repeat it here. I know some of you will be asking, what is the full meaning of VRRM, this and this and that. Definitely, even if I did not say it in this video, definitely you can as well do it as your own assignment and help yourself. So in that case, I repeat, there are two types of, that is power diode voltage rating, and there are two types. Number one is repetitive peak inverse voltage, repetitive peak inverse voltage, and the second one is non-repetitive peak inverse voltage. And the the repetitive one, it has VRRM, while non-repetitive one has VRM. Now, how did they work? Now, the repetitive voltage is applied to the diodes sustainably. That is, it is applied to that diode sustainably. Now, what do you understand by that word sustainably? Now, in that case, do you know that the major work of diode is sometimes, or it convert AC to DC in most electronic circuits. including in our laptop, including in our desktop, including in our electronics, and let's say television, and numerous to mention. That is the major work of it. Sometimes we have half half bridge and full bridge. So in that case, that is to tell you that diode himself, it received AC current, pure AC current. Now, in this section, where this one is telling you that the repetitive voltage is applied to the diode sustainably, which means it is this one that accepts that work of AC current, which converted it to DC. Because in the same circuit there, once it has converted it to DC, other areas or where diode is found, you also know that there are some diodes that also use DC voltage. So what I'm trying to explain here is repetitive is simply to use AC, while non-repetitive is the ability of the diode to block reverse voltage. It is the ability of the diode to block reverse voltage. Instead of the voltage will return back to the source, now the repetitive voltage, it has the ability not to allow the voltage to go back to the source, and it will remain in that circuit except that switch, or except the electronics gadget has been switched off. And that is a difference between the non-repetitive and repetitive um, um, inverse and peak voltage inverse or whatsoever thing. That is how, that is just their work there. Repetitive peak inverse voltage and non-repetitive the same. Their difference is one will allow the AC current to come in and it will convert it to DC, while the other one will not allow that current, or the voltage will return back to the source. It will block it. It works as a blocking mode. That is in terms of revising the voltage. That is why I say the repetitive and the non-repetitive voltage is the ability of diode to block reverse voltage, and that is what it does. So the power diodes are usually mounted on the heat sink, not all of them, depending. The power diodes are usually mounted on the heat sink to dissipate power during diode operation. Sometimes once you have seen it on the process, once the diodes have received voltage or current on it, now since it has mounted on that, it is called a heat sink. As long as that diode is on motion working, it will be dissipating heat to that particular power, to that particular heat sink. From there, the diode will work effectively. It will work as if nothing is happening. But irrespective of how it works, I believe that once the lifespan of that diode has expired, it will break down. That is to show you that in every point in time, no matter how strong that thing is, definitely there must be a breakdown at a point as well. So in that case, what I'm trying to say here, it also uses heatsink to dissipate power during diode operation. Now, this is a classification of power diodes. How do we classify a power diode? Because in this classification, it will enable us to know how many types of power diodes. It might also be more than this, but this is the one for the moment I know. And how do we classify, or the classification of this power diode? It is based on the reverse recovery time. It is based on the reverse recovery time, the process of manufacturing, and the depletion region penetration in reverse bias condition. If you are a good student, maybe you are an electronics student, you are in electronics, let's say from year 3, year 4, final year, and so on and so forth, you will at least you will understand exactly what I am saying. Now, for a power diode to be classified, whether types of diodes or in any means or in any way, it is based on the reverse recovering time, how it recover, and the process of manufacturing, depending on the manufacturing, and what the displacement layer. The displacement layer is in between the positive and the negative of that diode. That is the displacement layer, the displacement region, and penetration in reverse bias condition. So I want you to get this in case once I'm to classify it or tell you types of power diode, you will not miss. You will not say you are lost on that. So types of power diodes, and I said three types of power diode for now that I know. The number one is standard or general purpose diode. The second one is fast recovering diode, and the third one is Schottky diode. All these things are based on what I just said here before. They are based on the reverse recovering time and the process of the manufacturing. The third is the displacement region in which the penetration in reverse bias condition, and that is why it has standard or general purpose of diodes and fast recovering diodes and Schottky diodes. So in this Schottky diodes, I will treat Schottky diodes on a different topic altogether, because Schottky diode is very good topic, and I will tell you much more about it when I will discuss on the Schottky diodes, but I will discuss it briefly based on what we are discussing. Now, the general purpose diode, these diodes have which reverse recovering time around 25 microsecond, around 25 microsecond, and you know what that means. Microsecond, that is the recovering times of this general purpose is very fast. It recover immediately without time wasting, and that is why it is called general purpose diodes. Now, therefore, they are applicable in low frequency. All these ones are used in low frequency up to 1000 kilohertz, and low speed operation up to minus 1000 minus 1 kilohertz. So the range of this general purpose diode, it works from 1000 kilohertz to as low as minus 1 kilohertz. So now we are now in fast recovering diodes. These diodes have quick recovering arc due to their very small recovering time, due to their very small reverse recovering time, less than 5 microseconds. This one I don't want to repeat it again. This is microseconds. Due to the time of microseconds. I repeat, these diodes have quick recovering arc due to their very small reverse recovering time, less than 5 microseconds. Used in high speed switching application. They are also used in high switch application, depending on the kind of switch. It could be I don't know, maybe electrical, maybe changing power and so on. It could be anywhere, but they are used in high switch operations. This the Schottky diode, depending on the penetration of the displacement layer, are revised based on condition classified in two types, just as I repeat, the power diode, depending on the penetration of the displacement region, are revised based on condition, are classified into two types. Because if you remember, before we go straight to this particular section, we discuss first thing what we discuss is about the displacement region penetration and so on and so forth. So in this a shaky diode or shocky diode, it simply means that for before we can classify it, there must be a condition that that is attached to it. It is based on penetration of the depletion region are revised bias condition are classified into two. Let's look at the two first. The one is punch through diode. Punch through diodes where the width of the depletion region at the breakdown enter into the positive N layer is known as punch diode. What do you understand? Because sometimes some of us don't really understand how it is. We might graduate from university. If they ask us to explain all these things, it will take us, in fact, it, 6 months to explain it the way even the common man will understand. You know that in manufacturing of this power diode, it has positive and negative. So in that case, there are some region in which instead of that N to take a negative mark or a negative mark, it will carry a positive mark. That is where this point region come from. And if you remember from the condition given above in terms of classification, and you can also recall what I said here is penetration of the depletion region are revised. So on the process of that revision, that is where this end that are supposed to take the symbol of negative, it will take the symbol of positive, and that is where the punch comes. It has to come inside, because where the width of the depletion region are the breakdown, once something is breakdown enter into the n type layer is known as a punch through diode. Non-punch-through diode, a diode where the width of a depletion region at the breakdown doesn't go through into the adjacent. You know what that adjacent mean? When they were facing each other, because in times of the real power diode, it has positive, it has a three four region depletion region. One is positive, while the other ones are negative plus positive, negative plus negative minus. That is p plus n negative, n positive, and n negative, depending, and that is from the power diode section. So in that case, now what I'm saying here is the depletion layer at this breakdown doesn't go through into the adjacent again. It remains where it is, and it is usually called non-punch through diode. The other one that goes beyond, that goes at the adjacent, that move from his own region to another region, it is called punch through diodes. And those are just the two differences that I think you need to understand what I mean in that side. So in this case, in this moon, the drive region is the drive region width is extra than the highest width of the depletion region. Therefore, the depletion region cannot enter into adjacent again. Although I have explained this is just a write-up to make it up. But the truth of the matter is, on the process of that breakdown voltage, this particular one, this non-punch through diode, it doesn't have the capability, or it will not restart. It remain where it is, while the other punch through diode will jump, will move from his home side to another central, another region. So those are the two different aspects of it. Now these are applications of power diodes. Where can we use power diode? The number one is in power electronic circuit. It can be used as a rectifier. I have said this. It can be used as a rectifier, being converting AC to DC. In terms of that is used as a rectifier in converter circuit. And it can also use as voltage regulation circuit. It can also use as flyback and free wheel diodes, reverse voltage protection. All these things are power diode application. And I believe that if you do not understand it first, you can rewatch the video and you will get it or you will understand it. I repeat, in terms of this application, it is used in power electronics. It can be used as a rectifier, converting AC to DC. It can be used as a rectifier and a rectifier circuit, and it can also be used as a voltage regulation circuit, and it can also be used as flyback slash freewheel diode, reverse voltage protection. All these things are application of power diodes, and this is where we'll end today's video on power diode. Please, if you like my video, subscribe to my channel, comment, like and share. Thank you once again for watching my video. See you next week.